Welcome to section 5.5.1, absolute value transformation. We're going to continue with the transformation, but in this section, we're going to mainly focus on reflection. Now, what I wrote first is the parent function, f of x equals to the absolute value of x. So there's going to be two functions that we're going to look into. The first one, the new function, I'm going to write g of x equal to negative absolute value of x. So if we closely examine the two function that's written here, you see that in g of x there's the negative sign. But let's look specifically where it's located. The negative sign is outside the absolute value line, basically in front of the function. Now the reason I'm specifically saying that is because there's going to be There's going to be reflection in regards to this one where the negative sign is outside the absolute value lines or the outer absolute value lines and in front. And then we're going to talk about the other one later on. But that is basically the difference between f of x and g of x. So let's talk about the coordinate points and how the graph would look like. So I'm going to set up my xy table. And I'm just going to simply do 3 points. Now, f of x and g of x, the only thing that's similar is their vertex. Since we have f of x is the absolute value of x and g of x is the negative of absolute value of x, then you can say the vertex is at 0, 0. So we just basically need to find two coordinate points. Since 0 for the x is in the middle, I can do one lower, which is negative 1. And then one higher, which is positive 1. Alright, so let's do the first x value. X equals to negative 1. So I'm plugging negative 1 into x. And I'm plugging into the g of x function. So negative absolute value of negative 1. And again, the absolute value makes the number inside become positive. But I still have the negative outside. So I'm going to have the negative here, parenthesis, now it's a positive 1. Next, we have the negative that's from outside, we're going to distribute, so it's going to be negative 1. So that's my y value. Alright, let's work on the second x value. So x equals to positive 1. So I'm plugging in positive 1 into x for the g function. So negative absolute value of positive 1. So again, the absolute value just makes the number inside become positive, but I still have the negative outside, so negative parenthesis positive 1. Next, I'm going to distribute the negative to the number inside, so it's going to be negative 1. So I have my coordinates right there. So now we know that we have the graph of the parent function. But let's look at what happened to the graph when there's a negative that is outside the absolute value. So I'm going to use these 3 points here. Alright, so let me plot the points. So we have negative 1, which is right here. Then 0, 0, which is again the vertex. And then 1, negative 1. So 1, negative 1. So if I were to graph this, I'm going to start from the vertex in the middle, and I'm going to connect to the left point to make my left graph. And then from the vertex to the right point, I'm going to make my right side graph. So now if we look closely to the graph, closely examine the axis, we notice that the parent function, it opens upward, but when there's a negative that is outside the absolute value lines, basically in the front, then what happened is that now the graph is facing downward, going in the opposite direction. So if you were to closely examine this graph with the graph of the parent function, then the transformation is that it reflected across the x-axis. So let me write out the transformation. So what was the transformation from f of x to g of x? Now keep in mind, f of x was just the absolute value of x, then g of x was negative absolute value of x. So the transformation was reflected across x-axis. Now you could also write flip over or flip across x-axis. So that's basically the transformation whenever you have a negative that is outside and in front of the absolute value lines. So you can say reflect across x-axis or flipped over across the x-axis. So that's all you have to write for the transformation whenever you have a negative in the front and outside the absolute value lines. So in the next part, now I'm talking about where the negative is inside the absolute value line, but also in front of the x. So again, here's the parent function, f of x equals to the absolute value of x. Now the new function, h of x equals the absolute value of negative x. You can also rewrite this as h of x equal the absolute value of negative parenthesis x. So the reason I include the parenthesis is that we're going to have some transformation where the negative is going to be outside the parenthesis, and then you're going to have a number inside. But this is where we have to be very careful. Now, because I'm talking about in terms of when we're going to be working with quadratic, and quadratic will be used in parentheses. Now, in absolute value, we have the vertical lines. But again, the negative is inside the absolute value line. So this is going to be the other type of reflection. But keep in mind that the negative is in front of the x. So whenever we have a number with the x, we have to include the parenthesis. So that way we can identify the proper transformation when you're identifying all types. So I repeat that when you have a negative inside and it's in front of x, while there's a number with the x, you want to have the correct format in order to identify the correct transformation when you are identifying all types. So let's talk about the graph for f of x and h of x. So for f of x, which I'm going to graph on the left, it's simply a graph that looks like this. Now for the graph of h of x, if you look closely, the graph looks very the same to each other. So basically there is no visible difference between f of x and h of x, even though there's a negative inside the absolute value line. And the reason is because there's no number with the x that's inside, so it's kind of hard to see the transformation in terms of if you were given a graph. So if you were given a graph, you wouldn't know if there was a reflection at all if it was just the absolute value of negative x. So let's talk about if we have a different function where there is a number inside the absolute value line with the x, but also have the negative sign inside. Alright, so in this next part, I have the original function and the transform function. Now, for the original, this is k of x equals the absolute value of x plus 3. And the transform function, we have m of x equals the absolute value of negative of x minus 3. So let's look closely at the transform function. You see that we have a negative sign inside the absolute value line, but also in front of x. Since there's a number with the x, you can see how I have parentheses here on it. And I'll explain why the importance of parentheses. So if we compare, they don't look exactly the same. But if I were to distribute the negative sign in the transform function, this is what we're going to have. M of x equal to the absolute value of, and again, if I distribute my negative sign to the expression inside of parentheses, I'm going to have negative x plus 3. Now, if you were to compare these two functions, they are almost identical. The only difference is that m of x has a negative in front of x, while k of x does not. Now, again, here's the importance of having the parentheses, is so that you can identify the correct transformation. So let's talk about k of x. K of x, when you see it's x plus 3 inside, that means that it translates 3 units to the left. Now, if I were to use the function that's written in blue, negative x plus 3, you would say that it translates left 3 units. And again, we're going to ignore the negative for the moment, but talk about the plus 3. So if you say translate 3 units to the left, then that is not correct, because we have a negative right here. So let's go back to the function that's written in pink, where you see how it's negative parenthesis x minus 3, close parenthesis. That is the correct form. So if we look closely, you can see inside the parentheses it's x minus 3. So that means that it actually translates 3 units to the right. So that's the correct transformation. So that's the importance of having parentheses whenever you have a negative inside the absolute value line, in addition a number with the x. So it's very important that if you ever have something like that, make sure that you have parentheses, so that way you can correctly identify the transformation. So over here on the left, where it says x plus 3, 3 units to the left. Whereas over here, negative is in front of x, but we have parenthesis x minus 3. So the minus 3 clearly states that it's going to be 3 units to the right. And you'll see why in terms of the graph. Now, just a little review. If I were to identify the vertex, so remember, this is the vertex for the x, and then the number behind it. So the vertex for k of x is negative 3, 0. And then if I were to use the vertex for m of x, so the vertex here will be positive 3, 0. And the reason we have 0 for the y is because we have no number behind the absolute value, but you can simply say plus 0 if it helps. So that's the vertex for the transform function. Next, we're going to do our xy table to find the coordinate points. And then we just only need 3 points. Since I have identified the vertex, this goes in the middle, 3, 0. So if I were to do the other x values, I would do one lower, so at the top is 2, and then one higher, so it's 4. Alrighty, so let's start plugging in the x values. So I'm going to do the first one, x equals to 2. And now I'm going to plug into the m of x function. So I'm going to write exactly what I have. So absolute value negative, parenthesis, 2 minus 3, close parenthesis, and then absolute value. So I'm going to do this one step at a time. So absolute value with the negative. I'm going to simplify the inside of the parenthesis. So 2 minus 3 would be negative 1. Then, again, I'm still working inside the absolute value. So negative of -1 will be +1. And again, the absolute value just simply makes the number inside become positive. Since I don't have anything to distribute from outside the parenthesis, then it'll just be +1. Alright, so next I'm going to do x equals to 4. So I'm plugging in a 4 into the x of the m of x function. So absolute value of negative parenthesis 4 minus 3 close parenthesis. So absolute value negative. I'm going to simplify it inside the parenthesis. So 4 minus 3 is +1. Then continue to work inside the absolute value. So negative to the +1 will make it -1. And again, the absolute value makes the number inside become positive. So I'm going to have parenthesis +1 close parenthesis. Since I don't have anything to distribute from the outside, I'm going to drop the parenthesis and I'll just write the number. So +1. Alright, so I got my corner points right here. Next, I'm going to graph these corner points. In addition, you're going to have the graph shown for the original function, and we're going to talk about the transformation. So, here on the left is the graph for k of x. Now I'm going to plot the graph for m of x. So, using the points that we found, so 2, 1, which is right here, and then 3, 0 is going to be right here, and then 4, 1 is going to be here. Now again, 3, 0 is the vertex. So if I were to graph, I always start from the vertex. So I'm going to zoom in for y'all. So here's my vertex. So if I were to connect to the left point, I'm going to make my left side like this. Then from the vertex to the right point, I'm going to make my graph for the right side. And of course I'm including my arrows because the graph goes on forever. Alright, so let's talk about the graph. And I'm going to move it right here. Alright, so the graph on the left, k of x, that's the original graph, where it was let me write right here. Absolute value of x plus 3. Whereas for m of x, it's the absolute value of negative parenthesis x minus 3, close parenthesis, and then close absolute value. So, the only difference between these two functions is because of that negative. So, since the negative is inside, if we look from the transformation from k of x to m of x, we see that it didn't really translate it units to where the vertex is at 3, 0. Again, from the previous part, I said that whenever there's a negative, it's going to involve with reflection. So if you look closely, here's the y-axis between these two graphs. So if I started here, so if there's a negative inside the absolute value line and in front of x, like in this example, basically what happened is that it reflected over the y-axis. So it didn't translate, it didn't move or shift to the right. Again, when there's a negative, that means it's going to be a reflection. So a negative inside the absolute value line and in front of x is going to flip or reflect across the y-axis. So that's the visible transformation. So let me rewrite the function. So what was the transformation, or I would say the visible transformation from k of x to m of x? So the transformation was in terms of reflection. I'm only talking about in terms of reflection. Reflected across the y-axis. Now you could also rewrite it or state flipped over or across the y-axis. So that's what happened is when you have a negative that is inside the absolute value line and in front of x. It's reflected across the y-axis, or you could write or state flipped over or flipped across the y-axis. So next I'm going to do some examples in terms of identifying with reflection. Alright, so let's take a look at the examples. Here we have g of x and h of x. What we're also going to identify is reviewing from translation. So let's look at g of x. We see we have a negative that is outside the absolute value line. So let me underline that in blue. Since there's a negative outside in front of the absolute value, this one's going to be reflected across the x-axis. And then we have inside the absolute value, it's x minus 4. So since it's minus 4, that means it's translated right 4 units. So that's the only transformation that you can see in g of x. So we only have two transformations. Reflected across the x-axis and then translated right 4 units. Now let's talk about the other example, h of x, where it equals to the absolute value of negative of x plus 5. So this time we have the negative that's inside the absolute value line but also in front of x. So since it's inside and in front of x, then this one would be reflected across the y-axis. Now don't forget, we also have the x plus 5 inside the parenthesis. Since it's in parentheses, I can now correctly identify the transformation. So since it's plus 5, it translated left 5 units. So that's all you have to do when given the function or given the equation. Here we only have two transformation, so I just wrote out the two transformation. Reflected across the y-axis and then translated left 5 units. So that's all you have to do for identifying transformation when given a function. So in this next example, say that you were given transformation and now you're asked to write the equation or write the function. So let's talk about the given transformation. So the first one, it says translate left 7 units. The second one is translate down 2 units. And then the last one, reflect across y-axis for absolute value of x. So using the given parent function, the absolute value x, we know what our function has to look like. Again, since we've only been working with absolute value, we already know what the equation look like. But keep in mind that we're also going to be working with another function, quadratic, in this unit. So we know it's going to be the absolute value. So let me write out. So you can use any letter. So say I use p of x equal, so the absolute value with the x. Now it says left 7 units. So just similar to this one right here, where it's left 5, I'm going to write x plus 7. And then where it says down 2 units, so down 2 units, that means that it's going to be the number that's going to be behind the absolute value. Since it's down 2 units, that means it's going to be minus 2. Now, it says reflect across, so I'm going to underline reflect across y-axis. So it's going to be similar to this, where the negative is inside the absolute value, but I have to include parentheses on the x plus 7 because there is a number with the x, so I want to make sure that the negative is in front of the whole thing, so we must include the parentheses. So my answer is p of x equal the absolute value of negative of x plus 7 and then minus 2. So that's my answer. So be extra careful whenever it says reflect across the y-axis. In the event you do have a number inside with the x, then when you're going to put the negative, make sure to include parentheses on the x and the number.